Hi, I'm Jack Heslin, founder of the online community, the AI Conversation. The AI Conversation is a neutral, objective environment where we invite people of all kinds of backgrounds from all different sorts of organizations to share what they're learning about AI, but also to learn from what we know about AI so that all together we figure out the best way to use these very powerful tools, not just in our professional lives, but also in our day-to-day personal lives. Recently, it was suggested to us that before we show people how to use AI, maybe do some basic modules on what is it? What are some of the concepts of artificial intelligence? So as some of you might recall, we started that in our introductory module with just the basic elements of what makes up this AI pyramid. And then we said we would get into it more deeply per building block of the pyramid, excuse me, and that's exactly what we're doing here. Machine learning is the foundational technology that powers modern AI. Just like the Clydesdales were the powerful workhorses that drove the Industrial Revolution, machine learning is the force that drives today's AI revolution. And in this module, we'll explore how these digital workhorses, which is the right analogy, process data, learn from experience, and enable more advanced AI technologies to function. Now, there we go. Come on. At its core, machine learning is about teaching computers to learn from experiences rather than being explicitly programmed for every task. So think of that Clydesdale analogy. Those powerful horses could learn to handle different tasks through training. ML systems learn to recognize patterns and make decisions through exposure to data. This fundamental ability to learn and improve is really what brings us to this new frontier of computing, which makes machine learning the backbone of modern AI applications. So machine learning, this idea isn't new. It actually goes back to the 1950s, where people were thinking, how do we create systems that kind of perceive the world or think like the human brain? It was a long, slow process. But then by the 1980s, with the development of neural networks, we started to go in the right direction. But by this century, we revolutionized the field with big data, increased computing power, advanced algorithms that led to the machine learning capabilities we see today. This evolution has come far in a very short amount of time, but it's really in many ways still just taking off. Now, if you look at this color-coded display on the screen, you can see the major programming languages, Python, R, and Julia. These make up the primary languages that in machine learning development. Python, by far the most common, by far the most popular. It's got a readable syntax, enormous libraries to draw from. R excels in statistical computing and data visualization, while Julia brings in speed and efficiency for numerical computations. What we're trying to communicate here is how these languages work together in a modern machine learning environment. Now, machine learning isn't just one thing. We say it comes in four flavors, if you will. The first is called supervised learning. This is like the student learning to solve a problem from data that's been labeled, and you can kind of make a prediction from that labeled data. Unsupervised learning is more like an explorer trying out, looking for patterns. What do we have here? But then we get into reinforcement learning, which is learning through trial and error. It's how computers learn to play chess against themselves. Finally, you have the semi-supervised learning, which combines both labeled and unlabeled data. This is like having some solved examples, but also figuring things out on yourself. This network visualization we have, this diagram, shows how these systems basically work with each other and interconnect. Now, if you look at this grid of applications, we can see that machine learning touches nearly every aspect of our lives. Predictive analytics helps forecast anything from sales to weather patterns. Pattern recognition spots trends in customer behavior. Recommendation systems suggest your next favorite movie or product. And natural language understanding powers that virtual assistance we use every day. So each icon in this diagram here represents a different way, even though they might not have a lot in common, that use a machine learning algorithm to power it, to make it work. Now, why do we have a glowing brain on this slide? Well, what we want to express here, what we represent, is how machine learning enhances our abilities. We see 5 key advantages: automation of complex tasks, pattern discovery in huge data sets, scalability to handle massive amounts of data, adaptability for different changing conditions, different tasks. So what we're trying to point out here is that this is an incredibly adaptable, versatile technology. Now, it's very important to understand that every technology has its limitations. Machine learning is no different. What we're saying here is that machine learning depends on data quality. GIGO, garbage in, garbage out, is alive and well. It can't do better than the data it's given. The computing resource requirements for machine learning are huge. It is expensive, time-consuming, costly to program ML models. Then you have what we call the black box problem, coming out with suggestions or outputs that we quite frankly don't understand and don't know if they're right. But when you put it all together, the way we go forward here is that machine learning is simply going to continue to evolve and evolve and evolve as it gets integrated with more other AI technologies, which is going to create more powerful applications. I mean, there's no way around that. So the limitations are things we have to face, but as I like to say, this genie is out of the bottle. And what we're trying to say here with this pyramid structure is that all AI advancements build upon this machine learning foundation. So, what does this bring us back to? Well, it brings us back to our Clydesdale, plowing through the fields of binary code. The visual reminds us that just as Clydesdales transformed agriculture centuries ago in their day, machine learning is what will transform the digital world. Every advanced AI technology, every one of them, and we'll discuss this in the coming modules, relies on these machine learning workhorses for doing the heavy lifting. And for those of you who are curious, the prompt here for where this Clydesdale, our binary Clydesdale horse came from, was from Bing Image Creator, and we provide the prompt here if you want to try it yourself. Okay, hope you got something out of all that. In our next module, we'll be talking about neural networks and deep learning. That's the next block on the pyramid. My name is Jack Heslin. Thank you very much for joining us, and you should check out the AI Conversation, www.theaiconversation.com. Would love it if you joined us. Thank you very much, and stay well.